Good evening, juniors. This is Mr. Kim. Hopefully, you guys did well on the ELA portion of the NJGPA test. This video is mainly used for the purpose of it is to go over the NJGPA test with you guys. I went over my version of the test, so you know those small portions of the trig, sine, cosine, tangents, as well as the linear, quadratic, and exponentials, and all those wonderful things. What I want to do is I want to go over the actual NJGPA that was provided by the New Jersey Department of Education. This is really the only practice test is available online. So I will provide you guys with the link in the description for where to access this file, or I will provide the file on Teams for you guys to use. So I want to first get started off with the question that looks like this. So this is a geometry question. I know that I did this in the class before. So this is which of the following is the zeros of the function? Select all that apply. Now, the zeros of the function, honestly, is coming from the function here, where one of the zeros you have to obviously know it's going to be 6. These, you can factor it into x plus 4 times x minus 2. Remember, two numbers multiplies to -8, but adds to give you +2 there. So that's +2 and -4, which means you're really going to just put a and d and move on. All of the other points, like these are not even zeros. So zeros are always going to be x-intercepts. Please don't get them mixed up with what we call y-intercepts. And obviously C and E are not part of the solutions that's given to us. So, or C is also a y-intercept. So we're not going to pick that one. So the answer is A, B, and D. Let A represent a non-zero rational number and let B represent an irrational number. So which of the following could represent a rational number? The correct answer here was D. I'm gonna just kind of swiftly go over this because when we say an irrational number, I want you to think of numbers that is actually not a fraction. That is what it means to be an irrational number. So supposedly, let's say that we are looking for, I don't know, let's say like B is equal to pi. 3.1415926, blah, blah, blah. I mean, there's no way that you can replace that with a fraction to represent what pi is going to be. Another classic example of a rational number is a square root of 2, because it's 1.414, and then it just keeps on going on, and there's just randomness within the decimal values. So that's really the only reason why what distinguishes from rational to irrational numbers. So how can I make this to a rational number? Well, even if you put a negative sign in front of an irrational, it's not going to make any difference. Adding an irrational number to an irrational number will still end up being an irrational number. A times B, well, A represents a non-zero rational number, it says, and B represents an irrational number. So if I multiply any rational with irrational, irrational triumphs over. So irrational, think of it as like a really crazy number of decimal points coming afterwards. And when you multiply that with any sort of a sensible number, it's still going to give you crazy load of decimals afterwards. And B squared is the only answer because, like I said, one classic example is square root of 2 that you can plug in for irrational number. So then B squared will be 2, which is classified as an integer / rational number. Part B, consider a quadratic equation with integer coefficients and 2 distinct zeros. If one zero is irrational, which statement is true about the other zero? The other zero must be irrational as well. The thing about irrational values is that when one of the values actually turns out to be an irrational number, for example, like let's say square root of 2 or anything like that, there should be something called a plus and a minus in front of it, which actually provides you with the plus and the negative version of the irrational number itself, which means the other zero must also be irrational because one is the one with the positive square root of 2 and the other one is a negative square root of 2. Okay, number 3, which factorization can be used to reveal the zeros of the function? This one is simply factoring question. So I would probably suggest you to just kind of FOIL this out and pick the best one. And it seems like the answer choice that I can eliminate is A and C right out of the gate. Because if I'm talking about factorization, I wanted to have it in this format, which eliminates A. And when I FOIL this out, we can see how 3 times 5 at the end gives me 15. The negative sign in the front will make it -15, but I want a +15 at the very end. The only possible answer that works is the answer choice, I believe, B. When you FOIL this out, you get -12n squared. Outer is -20n. Inner is +9n. Last is +15. Add those two up, you get -11. Number 4, which expression is equivalent to that? This is actually quite simple. So it starts with 3x to the 5, and this is the only term with 3x to the 5th in this entire equation. So we're going to eliminate a and b because it simply does not have any 3x to the 5th in it. 8x cubed minus negative 6x cubed will give me plus 14x cubed. Bring us down to minus 7x squared. Make sure you distribute the negative sign. So the answer here would be C. Number 5, in this figure, triangle GHJ is similar to triangle PQR. So when they say similar to triangle PQR, that means that each of these corresponding letters matches with each of these corresponding letters. So when we're asked to find a tangent of H, notice how H is the middle letter with G, H, and J. Q is the one that therefore we're going to be using. So tangent of H is the same thing as saying tangent of Q, which the angle that they're talking about is this one. And so opposite over adjacent in this case would be 8 over 15. And that will be the correct answer here. So this will be the opposite side to this angle. That's your adjacent, and this is your hypotenuse. Make sure you guys know the SOHCAHTOA, and there we go. Number 6. So this was the question I did during the class. Which of the following is true? Select all that apply. So we're talking about, is it increasing or is it decreasing and things like that. Now the increasing is where if you were to draw like a stick figure from the left-hand side of the graph, if you were to move from left to right, are you going up the hill or are you going down the hill? Now it seems to me, starting from the get-go, wherever you are, all the way to the top of the peak, which happens at x equals 2, you're continuously on the rise. Which means f is increasing when x is less than 0. F is still increasing between 0 to 2. It's going to increase all the way up until it reaches 2. But when it actually goes over 2, so between 2 and 4, it's going to decrease. So between x is 2 and x is 4, notice how now the person is now decreasing and going downhill like this. And f is still decreasing when x is beyond 4. Based on the graph of the function, which statement is true? Select all that apply. So we are looking for what we call positives and negatives in this case. This means negative for y value, and this is positive for the y values. If I were to redraw this figure, I believe it was at 2, and you reach this maximum value here. Now, where is it negative? Negative happens when that function is below the x-axis. And you can see how when x is less than 0, because that's where the x is 0 is, -1, -2, -3, and you're constantly going to the left-hand side, that iceberg is below the sea level if you kind of catch what I'm trying to say here. If the sea level is at the x-axis, notice how that left-hand side is below the sea level, which means it's going to be negative on the interval when x is less than 0. Now, between 0 to 2, you see how the iceberg or that graph is above the ocean. So f of x is actually positive, also positive until it reaches 4, because when it hits this 0, it sinks down below sea level, and obviously it's going to be less than 0 when x is greater than 4. Okay, moving on. So which of the following are true? So I did not really go over this with you guys during the class. The reason for that is because what I wanted you to understand from these types of questions is that do you understand how to do something called dilation? So these two figures are obviously very close to one another, very similar to one another. Seems like if you zoom out on one of the questions, you can go from one triangle to the next. Now, how can I tell if it's going to be similar or not? Well, it's only going to be similar if the ratio of the sides are equal. Sorry, that's mean to say equal. So if I take KL to KL that way, is it going to give me the same distance as if I were to take L prime M prime to LM like this? And so that is really the main idea here. How much have I dilated and how much the ratio work? Are they all in synchronizations with one another? And there is a scale factor in which I also need you to understand. The dilation scale factor means how much have it gotten bigger. Like let's say zoom, it got twice as large or half as small. Those kind of things is what scale factor really means. You're multiplying each of these to the distance, and that's what we're trying to figure out. So the problem with these types of questions is that it's not easy to look at the distance for this, because first of all, let's take a look at K prime L prime. Notice how that's at 12, and this is happening. I think it's happening somewhere. Okay, I think that's happening at -2. So the entire x distance from here to that will be 14. And it seems to me that this is at 4 and this is 6, so that's 2. So if I use the Pythagorean theorem, 4 squared plus 2 squared and square root that, well, that would give me, what would that, 196 plus 4, so that would give me square root of 200 for this entire length of k prime L prime. Now, if you were to take 2, or I'm sorry, I should take k and k to L. Well, that distance is from 8 to -1, which is 9. And this distance up here is from 3 to 4, which is 1. And when you actually square root the result of this, you get 82 and you have to square root that. So that is basically the proportions between the two. Then when you take a look at one of the other triangle side lengths, LM to L prime and prime, I mean, you can see why this question gets so complicated, but just for the sake of, helping you guys out with this question, I will go over the answers with you. That is 15. So the distance from here to here, that's 12 to 15, which is 3. That distance is from -4 to +6, which is 10. Now, if you use your Pythagorean theorem, that's 9 plus 100. The same thing as saying 10 squared, 3 squared. It's square root of 109. Now, when you take a look at LM, you do the same thing. You kind of draw yourself this really nice right triangle. It's at 4, then it goes down to -3. So it's going to be 9 squared. And this is from 8 to 10, which should be 2, I believe. So plus 2 squared, and you square root that. That's 81, that's 85, and you have to square root that here. Now, the biggest question is the ratio from square root of 109 to 85 the same as square root of 200 to square root of 80, not 82? Because if indeed they are, the sides are moving by its own respective, well, altogether, the triangle itself is all being multiplied by the scale factor called k. We usually label it as k. And let's try to figure that out. So imagine for a second that I were to use the calculator, let's say. And I'm gonna take the ratio of this. So the smaller was 82 for this one, and it's over square root of 200 equals square root of 85 over square root of 109. Now, obviously, you can kind of tell that this is absolutely just simply not gonna work. Or maybe I am making a mistake here. That's 100, yeah, that's 109. And that is going to be 6. Right. Oh, no. That's 7. All right, so that's 7 squared. So that was my fault. I think I made that mistake. So 49 plus 5, which is 53. All right, so I'm going to use my calculator, and I'm going to change this to a 53. So square root of 82 divided by 200. You can put them together, and it's 0.64, which means to go from larger to smaller, you multiply by 0.64. Now, supposedly, if I do a square root of 53 divided by 109, do I get the same thing? Give or take, yes, approximately. So how much would this be? Well, there was a dilation of scale factor of 0.5 from the origin, or this is 1 point. This is definitely a dilation question, so there's not going to be a translation here whatsoever. But let's just check k prime m prime just in case. I just want to verify. So I believe that's going to be total distance of I think 17, and this distance here is from 4 to -4, which is 8. So 64 plus 17 squared, square root of that, that's 18.78. And then the small one here, that would be 3. That's 3, so it's 6. And then that's what? That's 11. So that would be 121 plus 36. Square root of that answer, and you get that. So when you do that over, obviously, this, you're going to get about 0.666. Now, what you want to understand here is that when you take a look at the ratio of each of those sides, they kind of tend to differ, but not differ by that much. One of the ratio was 0.64, other one 6.9, and the other one was 0.66. So there was a dilation of scale factor, 1.5 centered at the origin. I honestly don't know what to go about this because the numbers are honestly quite so different. So I'm just gonna say triangle KLM is not similar. And by the way, if you see this question, just skip it because there's just too much work involved. And I just want you to just skip that for now. Or better yet, if it's not B, It's either that or A and E combined together. Now, I don't know how generous they are. Maybe they're thinking that, hey, they're relatively close enough so that it's enough for you to say similar triangle. And because this is growing up by 60%, you can multiply each of them by 1.5. But honestly, skip number 7 because there's obviously a lot more interesting questions you should be able to do at the moment. All right, number 8, which of the following graph equations 5y minus 3x equals negative 15? Guys, you guys can just move this to the other side. 5y equals 3x minus 15, divide by 5, and you get this really nice 3 over 5x minus 3, which means your y-intercept actually happens at negative 3, and it's going to be a positive slope. The only solution that actually gives me is B, is because that's the only graph that goes through this the slope, I mean the y-intercept of negative 3 right here, which matches with that equation. All right, so this question, the figure shows line R, points P, T on line R, and point Q not on line R. Okay, so part A, consider the partial construction of a line parallel R through point Q. So what would be the final step in the conclusion? So the final step here is to have this, like, let's say you draw a line like this and you want to measure what this angle is. And these little marks are what they meant by doing it with the protractor. What would be the final step? It says to draw a line through P and S, draw a line to Q and S, draw a line through T and S, and draw a line to W and S. So what is this asking is that if I were to partial construction of a line parallel to R through point Q, so I'm drawing this line right here, what will be the final step in the conclusion? So draw a line through S and Q, I believe that's the correct one, because the drawing a line, it goes through the Q here, obviously, because it says it goes through the point Q, but also it needs to go through that angle called S. And because though that's the only way that you're going to be able to construct a parallel line to line R, that's the only option. Once the construction is complete, which of the reasons listed contribute to proving the validity of the construction? When two lines are cut by transversal and the corresponding angles are congruent, the lines are transversal. The two lines are cut by transversal and the vertical angles are congruent, the lines are transversal. Okay, the correct answer here would be A. So the reason for this is because there's a lot of definitions you need to remember for this, which I did not go over. But again, just for the sake of learning, corresponding angle looks like this. If I have two parallel lines, basically we call two railway tracks, you cut by something called transversal line. The transversal line cuts through both of those two parallel lines. Now, corresponding angle is basically, there's 4 separate angles that's created on the top side of this. And let's call this 5, 6, 7, 8. There's another set of 4 angles that's created at the bottom. The corresponding angle basically has the same shape or the same position. So how do I know which one is corresponding to what? Well, the 1 corresponds to 5 because if I were to take the top half and move it down, obviously with the 1 and the 5 will match up exactly. So when two lines are cut by transversal and the corresponding are congruent, the lines are parallel. This can only happen if these two, what we call corresponding angles, angle 1 and angle 5, if they're exactly the same, then you can assume that these two lines, line 1 and line 2, they're all going to be parallel due to that reason. Okay, so here I'm going to zoom in to this real quick. So this is parallel. That's sorry about my terrible handwriting. But yeah, that's what it comes down to. All right, so for number 10, which transformation will always carry the figure onto itself? So reflection across line R, that's obviously not going to do it because, you know, when you get this test, just try to draw it over on like a piece of paper, just flip it over and see what happens. You reflect it across line R, I mean, the shape of the trapezoid will not be flipped over like that, and it's going to look ugly. Reflection across line S, that certainly does actually make sure that this trapezoid is going to be the same. Rotation 180, 270, they're all not going to do the same. If it's 360, however, then obviously it would make sense. This would be 90 degrees clockwise. So it will be this way. I'm sorry, I'm drawing this entirely wrong. So this way would be the 90 degrees clockwise like this. So you can kind of take that shape and twist it 90 degrees. Then obviously it's going to look like this. Then obviously it's going to look like that. And then you go back up to your original. So it's going to just constantly cycle over and over again. If that's one of the answers at 360, you would have kind of been debating between B and E, but B is the clear winner here. All right, so that should end up for part 1. I do have a couple of more questions to go over, but I will stop the video now and have a good day.